Hello everyone. So today we will derive Schrodinger's wave equation. So psi x, this psi with respect to x is a sine 2 pi x upon lambda. We all have studied this earlier. So psi x is this. So if we differentiate this psi wave function with respect to x, what we get? We get this. We will simply apply the basic rules of differentiation here, nothing else. So yeah, now again we are differentiating it. So if we differentiate it again, then what we get? Minus sine 2 pi x upon lambda, and here 2 pi upon lambda. So we can write it, rearrange and write it in this way: minus 4 pi square upon lambda square into a sine 2 pi x upon lambda. Now just simply notice here what it's written, the same thing which is written here. So we can simply substitute the values and we can write it in this way. Let me show you. So this is actually wave function with respect to x. Now if we are collectively writing, where we are generalizing it as psi, we are not mentioning it that whether it is talking about the x direction or y or z. We are simply collectively rearranging all the equation. So if I simply write this, we get this. Note here, it is only psi, not psi x, psi y, psi z, nothing like that. Now we are generalizing it for psi. Now let us leave this here and come to the next point. So I am writing it here, making a line so that it may be distinguishable. Yeah. We all know what kinetic energy is it's half mv square, and from de Broglie equation we also know that lambda is equal to h upon mv. We all know this. So if I am simply squaring it on the both sides, we get this. And now I am simply substituting the values in this equation. So what we get kinetic energy as? Wait, let me rearrange it so that it might be a bit simpler. mv square is equal to h square upon m lambda square. Kinetic energy is half h square upon m lambda square. We all know what kinetic energy, it's total energy minus potential energy. So this is the value of 1 upon lambda square. Simply I am substituting the value of 1 upon lambda square in this equation. So what do we get actually? We get this. So this is our final equation. So this is Schrodinger's wave equation, which we derived just now. Thank you very much for watching this video.